PostgreSQL, or Postgres for short, is a wonderful open source relational database, and it's one of the most popular in the world. It's known for being robust, flexible, it's open source, and can handle anything from a small project to a data-heavy application in production. High availability makes sure that your database stays online, even if one of the machines in the cluster goes down. Securing the cluster with certificates ensures that all communication, even between nodes, remains secure. And putting it behind a proxy and a load balancer ensures that you can always get to your cluster, even if one of those nodes are down. But all of that is really hard to set up, at least until now. In this video, I'm going to walk you through step-by-step setting up a production-ready Postgres cluster. We'll start by provisioning the machines to host it, installing and configuring Postgres for high availability, and finally, we'll install and configure HA Proxy and Keepalived, making sure you can always get to your cluster. We'll also be securing all of the communication with certificates, and by the end of this video, you'll have a production-ready, resilient, scalable, secure Postgres cluster that's all set up and ready to host some real-world applications. I'm super excited to share this with you. There's a lot to cover today, so let's get started. Before we start installing things, I do want to cover some of the components that are involved within this high-availability Postgres cluster. First, we're going to start with 3 nodes. Now, you can scale this to almost infinity, but 3 is the lowest number of nodes that we need in order to have quorum when they vote for who's the leader. We'll get into that a little bit later, but just know we're going to have 3 nodes for Postgres. And those are represented here by the 3 Postgres blocks. Next, we're going to have 3 nodes for HA Proxy, and HA Proxy is a proxy or a load balancer that help distribute traffic to backend services. We're also going to install Keepalived on here, which creates a VIP or a virtual IP address, or sometimes called a floating IP, so that we can access this one IP and get to these proxies, which will then route the traffic to one of the available nodes. But if we drill in a little bit further, we can see some more of the components that we're using for our HA cluster. First is etcd. Now, what is etcd? etcd is a key value store that's distributed. So it's an easy and reliable way to synchronize key value pairs, especially configuration, across the etcd nodes. And etcd is used in our cluster to help track votes for who's the leader, as well as our configuration for our Postgres servers. And who manages that configuration? Yet another service called Patroni. Now, Patroni is a solution to help manage high availability for Postgres. Out of the box, Postgres is just a Postgres server. So Patroni is really kind of like an operator, managing leader elections, managing configuration, managing failover, managing replication. And so really it's coordinating all of the HA tasks for Postgres. So Postgres can just be Postgres, and Patroni is going to manage it and make it high availability by managing failover, managing leader election, managing replications, all of the really hard stuff. And it stores that configuration in etcd. And we will install etcd on these Postgres nodes. If you want to install these on their own nodes, you're more than welcome to, or if you want to use an existing etcd server or cluster you have in your environment, you're free to do that too. But I feel it's okay to install these on Postgres because this isn't going to be a shared service, and I need something to store this configuration that's distributed across many nodes. As you know, HA Proxy is a proxy, and it can do load balancing too, but we're going to do something else cool with HA Proxy, and we're actually going to check to see which one of our Postgres servers are up and which one is the leader. And so we're going to ask Patroni, hey, which one is the leader? And we're always going to route traffic to the leader. And that's how we're configuring this Postgres cluster, is we'll have one leader that does all of the writes and can do reads. And then we'll have many replicas that do just reads and replication. So the way that this works is if 2 is the leader, it's going to take all the read and write requests, send them back to the application, and everything's fine. And then it's going to replicate with all of the replicas or all of the read replicas that we add. And if this one goes down, Patroni will start an election and elect one of these new nodes, and then traffic will then be routed to that new node. And this is all seamless. We don't have to do anything. This is how it's going to work after we get it set up. And then if 2 comes back up, it will replicate the data from the leader. So this is a really cool pattern because you can add almost an infinite amount of replicas to synchronize this data back from the leader. And then if the leader goes down, a new replica gets chosen as the leader, so on and so forth. So super scalable, super easy to do. And then a quick call out on Keepalived. It is communicating with all of these nodes and making sure that these nodes are up so it can then decide who's gonna manage the VIP right here. And the cool thing about Keepalived is you don't technically need quorum at all. You just need at least 1 node up to have your VIP or your load balancer. So let's say, for instance, Keepalived node 1 is the master. All traffic will get routed here. But if this goes away, then all new traffic will go to the next in line, which is probably going to be 2 on the way we set up the priority. So then traffic will start going here. But if 2 goes away, 3 can survive on its own because it's not a quorum-based system, it's a priority-based system, and so it can survive with only 1 node. And so traffic will get routed here. And then if 1 comes back up, it then becomes the leader. So this is a pretty good resilient stack. Let's start configuring this and getting the parts and pieces in place so that you can get your cluster running. And before I forget, everything we're going to talk about today can be found in the documentation, and you can actually follow along, and you can find that in the description below. So we'll need 3 nodes for our Postgres servers and 3 nodes for our HA Proxy and load balancers. And these nodes can be virtual, they can be physical, they can also be LXC containers, which I'm running in my production cluster, but we're going to set up VMs today just to be sure that anyone can do it, even if they're not running LXCs. So I have 3 Postgres servers here, each on different Proxmox nodes. Again, doesn't have to be on Proxmox, but you can see each node has 4 gigs of RAM, 4 CPUs, and 16 gigabyte hard drives. And this is more than plenty. And these are all running on an Ubuntu server, the latest LTS. And if you want to install this on any other version of Linux, you're free to, but you might have to modify the commands for your package manager. So I just turned on Postgres 1. Let's turn on Postgres 2. And let's turn on Postgres 3. When you set up these nodes, you want to make sure that you have a static IP address for all of these nodes. We don't want DHCP. That would kind of be a nightmare because we're going to be using IPs a lot in this tutorial. But make sure you have static IPs. And then we'll need 3 HA Proxy nodes. Now, I set these up the exact same way, but these need very, very little resources. But let's start up these 3 nodes. And for reference, here are my IP addresses for those 3 nodes. My HA Proxy starts at 100, 101, 102, and those are HA Proxy 1, 2, and 3 nodes. And then Postgres starts at 103, 104, and 105, and that's Postgres 1, 2, and 3. And once those machines are up and running, we can start doing the installation. Now, we're not going to use containers for this installation, and we're not going to use anything like Ansible or any way to automate it. I have copy and paste, so copy pasta commands for you to copy and paste and install this using a package manager. Now, I might try to automate this in the future, but if I were to automate this now and just run a playbook for you, that'd be a pretty boring video. And plus, you wouldn't understand all of the components that were involved and how this kind of works, which is really helpful when you need to start troubleshooting, which you may in the future. So anyways, this isn't going to be automated. I'll have some stuff on the container way of doing this maybe in the future, but this is going to be just good old installs through our package manager. So I've SSH'd into all 3 nodes. It's probably a good idea to go into all 3 nodes at the same time. We're going to install Postgres on all 3 of these nodes. Now I'm going to copy this command right here, and I'm going to paste it into all 3 nodes. And what this is doing an update. It's going to install Postgres common, and then it's going to execute this script to add additional repositories to our app sources. Let's do that. Times 3. Here it wants confirmation for adding the apt repository. Say enter, 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 and then it updated for us. Then we'll update our repositories and install Postgres. Next, we're going to stop and disable the service. Wait, we just installed it. Why are we doing that? Well, that's because Patroni is going to own the lifecycle of Postgres, and we don't want a systemctl to manage the lifecycle of Postgres. So we're going to stop and disable. Patroni will manage it in the future. And if you have this enabled, you could run into problems. So we're going to stop and disable. Okay, now that Postgres is installed, that was pretty easy. There isn't much more to do with Postgres until we get to the Patroni configuration. So now let's install etcd. And a reminder, etcd is a distributed database, key value pair, that stores a lot of our configuration for our Postgres servers by Patroni, which it also manages voting in who's the current leader. So let's get etcd installed on all 3 nodes. First, we need to make sure that wget and curl is installed. This is going to be installed on most distributions, but just in case you don't have it installed, it's required, so we're going to install it. Next, we're going to get the latest release from GitHub. And at the time of recording it, it's 3.5.1.7. And what we're doing is downloading it from here in the release section, and then we're going to configure it locally on our machine. So if there's a newer version and you want to use it, just adjust the paths for the download. 1, 2, 3. Once we have this downloaded, we're going to move it inside of an etcd folder. And if we do an ls on each, we should have an etcd folder and then the archive that we downloaded. Next, we're going to move all of the binaries from inside of this etcd folder to user local bin, so we'll have them available globally and we can use it later. And just so you know, if we go into etcd, there are a few binaries. If we do an ls, you can see there's etcd, etcd_ctl, and etcd_util. So these are used for different purposes, but we'll see them here in a little bit. But let's go back up. And what we're going to do, again, is move these 3 binaries into our bin folder so we can use them. Let's move them. Let's move them. Okay, moved on all 3. Then we'll check the version of etcd we'll have, and this will also test to be sure that they're in our bin folder and they're accessible. So if we do an etcd version, we should see our version pop out on all 3 nodes. We do. And while we're at it, let's check out etcd_ctl or etcd_ctl. I don't know. I'm going to say etcd. I kind of want to say etcd_ctl, but I don't know. etcd_ctl. And we should see our version here. See our version here. See our version here. Cool. So that utility's there. And we could do the same thing for a util if we wanted to. So we can do it there, we can do it there, and we can do it there. So that means all 3 binaries are accessible to all of us. And that's just a quick way to check that. Next, we're going to add a user that etcd will run as. Instead of having it run as our root user, we're going to create a user and we're going to say, hey, your home directory is in var lib etcd and you're not able to sign in. So let's create that user really quick. User, user, user. Now that we have etcd installed and we have a user to run etcd, now we need to configure it on all 3 nodes. So we need to make a couple of folders here. One will be for our data and one will be for our certificates we're going to generate. So let's make those here, make those here, make those here. Next, we're going to do this step on our local machine and not on any of the servers. So we're going to generate certificates on our machine and then move those to those 3 servers. So don't do this on the server unless you know what you're doing and you want to move things around. It's a lot easier doing it on our machine than on those servers. And so on my machine, not the servers, I'm going to check to see if OpenSSL is installed. So I'm going to run OpenSSL version. And I can see I have a version, so it works. Now, if you need to install OpenSSL on your machine, it's pretty easy to do. I've left commands on how to do it on macOS, on Windows, and even on Linux. So make sure on your machine, you have OpenSSL installed. And then what I would do is create a folder called certs and then cd into it. And that's where we're going to keep our certificates that we're going to upload to our servers. Then after that, we're going to generate a certificate authority and then sign all of our certificates that we generate with that CA. Now, if you already have your CA and you can generate certificates easily, that's great. You don't have to do a lot of these steps and you can just move them into the servers where we're going to move them. But I'm going to assume you don't have a certificate authority and we're going to create some certificates ourselves and sign them ourselves so that we can use them to keep the communication secure. So first, we're going to generate a CA key. Then we're going to create a cert request, and I put the days to 7,300 days or 20 years. I think the default is 1 year, but I put 20 years so I don't have to worry about it. We should see in here we have our CRT or our certificate request and a CA, the private key. Now that we have this, we want to generate one certificate per node. They need to be unique. So what I'm going to do is first generate the certificate for node 1. Next, what I'm going to do is create a temp file really quick, and that's configuration for OpenSSL, as you can see here, where we can pass in this configuration. Now, the reason why I'm doing this is because we need to add some SANs, or subject alternative names, to these certificates so that we can add our IP address and our local host IP address. And that's important because otherwise these certificates will get rejected. So we want to make sure we add our IP address to the SANs. So let's cat out this file. And if we do an ls, we see our file there, and we can do a cat temp just to make sure we have contents in there, and we do. Then we're going to create a certificate signing request for this etcd node 1. We do an ls again, we can see we have that CSR now. Then we're going to sign the certificate with the CA that we generated. And once we sign it, let's check really quick to make sure we see our SANs or our subject alternative name. So if we run this command, then we can see we have our SANs and we can see our IP address. This is my first etcd node and localhost or 127.0.0.1. So this worked. Then let's remove this temp file because that temp file actually includes the IP address for node 1, and we need to do this for node 2 and node 3. Another call out, if you want to adjust your state, your city, your organization, and your OU, your unit, in your certificate, you can. But for me, it doesn't really matter that much, so I'm just going to use this. If you want to adjust it, here's how you do it. So now let's do the same thing for 2. Take note, that's node 2's IP address. Then verify node 2. I can see node 2 has a SANs of this node 2's IP address. Time for node 3. Check our SANs, and we have it, node 3's IP address. So if we list all of our files, we should see a CSR for each, a CRT for each, and a key for each. And then we'll also see our CA stuff as well. So make sure you see all of these files because we're going to use most of them. Okay, next up, I'm going to SCP or secure copy these files from here to the respective servers. And we're going to do it with a command like this. So this first command is saying SCP, the CA file, the CRT file, the key file, all for node 1, over to node 1 in the temp folder. So that's that. So copy those 3 files. Node 2 files. Node 3 files. Then after we've copied those files there, we don't need to do anything else local now. So we're going to go back into each node. If you have your terminal open with those 3 windows, just open that back up. So now in each node, we should see those certificates in /tmp. We see them on 1, we see them on 2, and we see them on 3. Then we're going to create a folder on each to hold these certificates. We're going to move all of those certificates to that folder. Then we're going to chown or change ownership of that folder, and we're going to do it recursively to the user etcd group etcd of that folder. And then we're going to chmod it. We're going to change permissions to make sure that this one has a 600 and the other one has a 644. And that's just so that this user can read those certificates. So let's do that really quick. Node 1, node 2, node 3. And you may want to check to make sure that those certificates are there. You could do an ls etcd ssl, and you could do this all 3 if you wanted. Now, before we start etcd, we need to configure it, and I'm going to do this through environment variables. So I'm going to create an etcd.env in that folder, so when this starts, it will apply these environment variables to that service. So first is the name of the node. Next, where we're keeping the data, our cluster for etcd, so all of the nodes that make up that cluster. So note the IP and note the port. The next one, we're setting our cluster state to new. So when we bootstrap this etcd cluster, we'll want this to be set to new. After it's running and the service is running, we'll change it to existing so that we're not trying to create more and more clusters. But keep this to new at first, we'll change it later. Next is a cluster token for initial configuration and bootstrapping. You could put this to whatever you want, but I put mine to etcd cluster. Next, we're setting up the advertise peer URL. So when it advertises itself, it's going to say, hey, I'm on HTTPS 192.168.60.103. And you'll want to update this with your IP address for your first node. Then it's going to listen on all interfaces over HTTPS. Then it's advertising the client URL to say, hey, I'm here, and this is my port. Then we're going to use certificates. That's why we set all of these up. We're going to use authentication for all of these, and this is why we set it up. And so all of our communication for our etcd cluster is going to be secure between nodes and in and out of the cluster. So let's create this config on node 1, and we'll paste it in there. So on node 1, let's create this environment file. Let's paste that in there, save. For node 2, let's grab node 2's config. And then for node 3, let's grab node 3's config, create the file, paste the config, write, out, exit. So now that this service will be configured when it starts up, let's actually create a service for it. So let's create a service file. And then here are the contents for that service file. This is a pretty typical service file, but a few callouts. Our working directory, we're going to set that to varlib etcd. Our environment file, that's what we just created. We're going to point to that environment file. And then the user and group is the user and group we created earlier, which is etcd, so this doesn't run as root. So let's paste that into the contents of the service we're creating. Write, out, exit. And this will be the same file for all 3 nodes. Right, out, exit. Next, we need to create this working directory since it doesn't exist. So we're going to create a directory, and then we're going to chown it or change ownership to this etcd user. So let's do that really quick. All 3 nodes. 1, 2, 3. Okay, so now after creating that service, we're going to have to reload the daemon or the process that monitors the service. I think that's what it is. And then we're going to enable the service we just created. Reload, enable, reload, enable, reload, enable service. Now that we've enabled that service, now we can start it. So let's start it on the first. Now, when you start it on the first, it looks like it's hanging. And this caught me up for a minute. It's actually going to kind of hang or wait for another node to join. And so if you start it on 2, you'll see almost immediately they both continue. So that's a good sign. Let's start it on the 3rd, and that's a good sign. So they're all running. Now let's check the status of our etcd service that we just created. So we're going to do a sudo systemctl status etcd status. Hey, looks good here. 2, looks good there, looks good there. So we have etcd running on all 3. Now let's check the logs just in case. I think it's really important you know how to check the logs. So here we're going to say journalctl, and we're going to say, hey, log out everything from the etcd service. And there might be a lot of stuff. If you want to do the last N100 lines, you can, and you can see it here. So can't see it here, but looks okay, no errors. We'll do it for all 3, and all 3 look pretty good. So now that etcd is running on all 3 and the service is successful, we need to check the status of the cluster. So let's check the endpoint on each of these etcd nodes and see what it says. Now, in order to do this, we're going to need to run the etcd-cutl. We're going to have to point it to the endpoint of localhost, and we're going to use these certificates so that communication is secure. And then we're calling endpoint health, that command to say, hey, how's your endpoint doing? So let's do it on the first. Endpoint is healthy. Let's do it on the second. Oh, you do it on the second, you're going to need to change your certs to node 2. And remember, these nodes are on that local machine. So node 2, that's good. And then if you do it to node 3, again, you're going to have to change your node number for your cert to node 3. If you wanted to make this even easier, you could remove that number from them altogether. But I did that initially so we knew which cert was which when we uploaded them to each respective server. So we look at 3, 3 is good. This is a very good sign. So we've checked each individual node, and each node says, hey, etcd is doing pretty good. Now let's check the member list. And so this is going to test to make sure that all of these nodes have joined the same etcd cluster. So let's check the etcd cluster member list. Hey, awesome. So we see 3 nodes in our cluster. Pretty cool. So we see Postgres 1, Postgres 2, Postgres 3, and that's just the name of the cluster. I named it that. You can name it anything you want in your configuration, and we can see the endpoints. Now, if we want to check, hey, who's the leader for this, we can run another command. So then I'm going to run another command, and I'm going to get the endpoint status and write it out to a table. And that table doesn't look great on this resolution, but if I shrink it a little bit, it does. You can see here are all 3 nodes. The cool thing is you can see who the leader is. So right now, node 1 is the leader as far as etcd is concerned. So pretty cool. We're in a good spot. So now that etcd is running on all 3 of our nodes, now we can configure Patroni to say, hey, Patroni, here's your etcd cluster to use for your configuration and for voting so that you can then drive Postgres for us. So let's do a couple of things for Postgres and let's do a couple of things for Patroni. So for Postgres, we're going to create a data folder and we're going to create an SSL folder. As you guessed it, we're going to generate some more certificates for Postgres so that communication is secure. Let's make the directories on all 3 nodes. And then on your local machine, let's generate some certificates. Again, this is not on the server, it's on your local machine, and you should probably go into the same folder that had all of your certificates that we generated before. So let's generate a server key or the private key. Then let's create a cert signing request. And here's what I was talking about a little bit earlier. If you wanted to specify all this information for your certificate, I don't. So I'm just going to hit enter a bunch of times. We don't want to challenge password here. And then if we do an ls, we should see a server request right here, and we do. Then we're going to sign the certificate and again, make it valid for 20 years. So let's sign that certificate. And you can see I just signed it, and you can see we have the server CRT, so we have our certificate. Next, we're going to do the same thing we did before. Now we're going to secure copy those to our Postgres servers again. So copying from my machine out to node 1, 2, and 3. Here we go. Now back on our servers, we're back into our 3 servers. Just for clarification, hostname, hostname, hostname. We're going to move those certificates into that Postgres folder that we created just above here. So we're going to cd into here, and we're going to move those files into the folder. So cd into temp, move, cd into temp, move, cd into temp, move. If you do an ls, you can see that those files got moved. Then we're going to chmod and chown these files. So we're going to set some permissions on those files and folders. First one, second one, third one. Now we have our etcd certificates and our Postgres certificates. If you remember a little bit earlier when we created those etcd folders and moved those certificates there, we actually set the owner to the etcd user. But now the Postgres user needs to access those certificates as well. So what we're going to do here is set an ACL to allow the Postgres user read-only access to those etcd certificates. So in order to do that, I'm going to install the utility called ACL on all 3. And then we're going to set an ACL saying that our Postgres user has read access to these individual files. So let's run this on node 1. And then on node 2, we're going to run the node 2 commands. And then on node 3, we're going to run the node 3 commands. Oop, not node 2, node 3. Now we have everything in place to install Patroni so it can create and manage our high availability Postgres cluster. So let's install Patroni on each. 1, 2, and 3. Okay, so once Patroni is installed, we're going to make a directory for Patroni to hold some configuration. So let's make that directory in etc Patroni, etc Patroni, etc Patroni. Then what we're going to do is create a config file inside of there. So first, let's create that file and open our editor. Open editor with this new file. So what are we going to put in there? I should probably explain this Patroni config before we just go start copying and pasting stuff. So this is the Patroni config that's going to configure Patroni, etcd, and also Postgres. So it's pretty cool. So first it's saying, hey, what's our scope? And this is going to be the name of our cluster. If we had multiple clusters, we would have different scopes. The important piece up here really is that we set our node name here. So this is my PostgreSQL 1, and then we'll have one for 2 and 3. Next is the etcd configuration, or etcd 3. We're going to list all of our hosts. So these are all of our host IPs of our etcd machines. Remember, it's our Postgres servers. Next, we're going to use the protocol of HTTPS because we want the communication to be secure. And in order to use HTTPS, here's our CA, here's our CA cert, and here's our key. Next is the REST API, and this is important because Patroni creates an API, or a web service, a REST API, that HA Proxy will actually call into to ask which one is the current leader. We're going to say yes, configure it, and listen on all IP addresses on port 8008. And so this one says, hey, my connect address for this specific node is our node IP over 8008. And then we're going to use a certificate for this. We're going to use our Postgres certificate to secure that endpoint. And we could have created another certificate for the Patroni endpoint, but I figured we have enough certificates already. And we actually need to generate this in a PEM file. So I'm glad I paused. We need to generate this as a PEM, a combination of our certificate and our key together. And we'll do that here in a little bit. Then there's some things for Patroni itself. But under here, the important piece is Postgres. And this is going to configure Postgres or Postgres server. So what we're saying is, hey, turn on SSL. We want that on. And here's the key and certificate for SSL. And then we're doing a PGHBA. And so what this is doing is actually configuring a PGHBA.conf file. What that is a config file on each server to configure the Postgres service. And so by adding this key in the YAML, it's going to bootstrap a config file with these values in it. So here are the values that are going to be in that config file. And the cool thing is that config file is actually stored in etcd and it's replicated and shared to all nodes. So what this is saying is for replication, we want to use the replication user, and we want to allow all of these IP addresses. So when the nodes need to synchronize data between nodes when there's updates, hey, these are allowed to synchronize, and they're going to use the account replicator, which we're going to show here in a little bit. And then we're allowing all connections from everyone over SSL. And this is kind of important because if you need to connect with a client, you either need to hard code that IP in here or just say that everyone's allowed. That's kind of up to you. I'm just making them all allowed for now, but you could scope this to your subnet, to your IP address, or whatever you like. But this is saying that, hey, anyone can connect from anywhere on localhost and any IP. Then initialize our database with UTF. And now going into Postgres configuration, listen on this port. Here's the IP you can connect. Here's our data ders, and we're going to create some users. And the first one is called Postgres. So this is going to be our Postgres super user account. And then we're going to use this password. I advise you to change this. You could change it now so that when it bootstraps this cluster, you'll have your password there. And then for replication, we're creating a user called replicator, and then we're assigning this password to it. I advise you change that too. And that's the replicator user we talked about a little bit earlier. Those are the important pieces of the configuration. Now let's copy this configuration to each node and pay attention. You're going to need one per node because some of the values changed. And I have comments there for things you should look out for or change. So let's copy node 1's config. And then back on 1, we're posting this into the Patroni config, and I'm going to save that and exit. Next is node 2's config. Then paste that into node 2's Patroni config, right out, close that. And then 3, I'm going to paste into 3's config, right out, save that. And I mentioned a little bit earlier that we need to create a PEM for the Patroni endpoint. And so let's do that really quick. So I'm going to run this command on each node. So let's create our PEM, create our PEM, create our PEM. Then we're going to apply permissions to this PEM. So make sure that Postgres user can also access this file. Then if we want to verify this PEM, we can, and I advise you do. So let's verify. And really, you're just looking to make sure that it is valid. I mean, obviously, you can go up and check the signature and compare it and see the validity and who the issuer is. But really, I'm just making sure that this doesn't throw an error. So all three look good. Now let's restart the Patroni service. And as soon as we do this, it should create our cluster. Okay, so let's restart it on 1. Let's restart it on 2. Let's restart it on 3. Okay, so let's check the logs on 1 by running journalctl, and we're using the user Patroni, and I'm doing a -f to follow. And if we look, we can see some pretty interesting stuff. So what I'm looking for right here is this log, and you'll see this repeated over and over and over, which is pretty cool. He's saying, hey, I'm Postgres 1. I'm the leader with the lock. So right now, Postgres 1 is the leader in our cluster. And if we look at 2, what we're looking for is I am PostgreSQL 2, a secondary and following Postgres 1. Good news for 2. And if we look at number 3, starting, there we go. So no action, I am PostgreSQL 3, a secondary and following a leader, PostgreSQL 1. So congratulations, we now have a high availability Postgres cluster. Pretty awesome. So now that we know that etcd is running, our cluster is running, and everything's running pretty good, now we'll need to go back to our etcd configuration and tell it not to create a new cluster every time it starts, to use the existing one. I mentioned that earlier, but what we're going to do is just quickly modify our environment variable file. And here where it says new, we're just going to change it to say existing. And we'll need to do that for all 3 nodes. Otherwise, it's going to try to keep joining or creating a new cluster each time. And it's kind of painful to figure out that's what's going on. Now, if we wanted to, on each node, we wanted to check that endpoint I was talking about from Patroni, we could run a curl, ignore self-signed certificates, and see if we're the primary. And so when we curl that, we get some JSON back. And in here, what we're looking for is, right here is the role is primary. So node 1 is currently the primary. And so if we wanted to check, even though we know, check node 2, which is 104, he would say, hey, I'm a replica. And if we checked node 3 on its endpoint, and we check there, he would also say, hey, I'm a replica. And that's very helpful because now we can configure HAProxy to query each one of these nodes to see who the leader is. So then it can direct traffic to the current leader, like that. So let's configure HAProxy really quick. All right, this is probably a good point to take a stretch or grab some more coffee or grab a drink because now we're on the home stretch and we want to configure HAProxy. So make sure that your 3 HAProxy nodes are on, 1, 2, and 3. Then you'll want to SSH into each of those nodes. So for me, that's 100, 101, and 102. If I check the host name of each, you can see HAProxy 1, 2, and 3. And for all 3, let's install HAProxy. And then for HAProxy, we're going to add this configuration here. And I should probably explain this because it took me a really long time to figure this out. So first, we're creating a front end called Postgres front end, and we're binding to port 5432. So this is saying, hey, on HAProxy, it's going to listen on port 5432 and then route that to the default backend. And if we look at the default backend, you can see we defined it right here. So the default backend is going to be a couple of things. One, it's going to be our Postgres node behind, which is here, but then it's also going to be the Patroni endpoint to check to see who's the leader. So this is how we do it right here. So these two are pretty common, but right here, we're going to define this check and we're going to say, hey, it's a get on /primary. Now, if you remember, that's where we were calling out to that endpoint on /primary. Then we're going to say, hey, we should expect a 200 or something's wrong or it's down. Then we're defining some timeouts, and these are really optimizations for the connect, the client, and the server so they don't hang forever. And here's where the secret sauce is. We're saying our server is Postgres 1, and here's the IP address, and here's the port 5432. So this is saying when we get something on the front end going to 5432, we're going to send it to the back end of 5432. Pretty obvious, right? But then we're adding this port directive, and we're also saying 8008, which is saying, oh, by the way, for our health checks, we're going to use port 8008, and we're going to check SSL, and we're not going to verify that certificate because it's self-signed. So that might seem easy to you, but that took me a little bit on how to figure out how to pass through the port of 5432 to our Postgres server while still doing our health checks over SSL. Now I did say verify none. This is because our certificates are self-signed. If you have an internal trusted CA or you're going to use a publicly signed one, I would recommend taking this off. But since we're using self-signed, we need to turn this on. So let's append this configuration to the end of the existing file for each node. So let's go to the end of this file. We're going to paste it. We're going to O, out, save, exit. End of this file, paste, write out, exit, save. End of the file, paste, write out, exit, save. There we go. So now we have the configuration on all three HA Proxy nodes. Now let's reload HA Proxy on each one of the nodes. There's 1, there's 2, and there's 3. Now let's check the logs just to make sure that everything's okay. And so what we're going to do is we're going to grep var log syslog, and we're going to look for anything that says HA Proxy in it. So let's go to 1, let's go to 2, and then let's go to 3. Now I have noticed these app armor errors in here from Ubuntu. They haven't really affected anything, but what we're looking for is errors, and outside of that, looks like everything's okay. So now we need to install Keepalived. And what Keepalived is doing is creating this load balancer or this VIP or this floating IP so that we can communicate with this IP and not need to know anything about HA Proxy behind, right? One of these could be down. It doesn't matter. If this one's down, if this one's down, it doesn't change this IP address. And this is why Keepalived is nice. So pretty easy to install. Let's install it on all three nodes. Let's install it on the first node and on the second node and on the third node. Next, we need a config file for Keepalived for all three nodes. In here, we're going to paste this configuration, and we have one per node. So first, we're going to enable script security, and that'll get rid of some warnings, but we're saying, hey, we're going to secure this script, and we're not going to run it as root. We're going to actually run it as a new user that we need to create. And what that script is doing is just checking to make sure that the other nodes are live, and I'll show you all of that. Next is that script I just talked about, and it's going to live here, which we need to create. So we're going to be checking this every 2 seconds, and that will determine if we're up or not. I'll show you that script here in a second. But here's really where we configure Keepalived. So we're saying the initial one is master. So I'm dedicating one of these nodes as master. I'm just going to dedicate one. We're saying, hey, listen on this interface. Now, if you're not using eth0, you'll have to change it with your interface name. Router ID, this is just in case you have multiple routers. I'm just going to set it to 51. So for priority 100, what this is saying is if one of the nodes are down or if the master is down, the one with the highest priority will become master until the master comes back up. So it's pretty awesome. Don't really need to vote. They just need to figure out what the priority is of the other nodes. And then I guess that's kind of voting, but it only takes one. And then authentication for each of these nodes to communicate with each other. And we're saying the auth type is pass, and the auth pass is this password right here. Now I said change there. We're not going to change the auth type. What we are going to do, and what you should do, is change the auth password. And right now, it needs to be 8 characters. I think it needs to be 8 characters alphanumeric. If you change it to anything else, you're going to go crazy figuring out why this doesn't work. So use 8 characters and make it alphanumeric. Then we're defining our IP address of this VIP or this floating IP. We're saying that this VIP right here, this floating IP, is going to be 192.168.60.110. And that will be the IP address that all of our applications or our clients are going to go to. Then we're saying, hey, our track script is running check HA Proxy, and that's this script right here is check HA Proxy. So really quick, we're going to do this for all three, and we'll talk about the script when we create it. So for node 1, let's grab this right here. Now node 1, we're going to paste that configuration there, save. Node 2, paste that configuration in there, write out, save. For node 3, we're gonna write out, save, paste, good. Now we need to create that script, and here's what the script is going to be doing. So it's going to actually check to see if HA Proxy is running or not. And so this is important because what Keepalived on each of them is saying is, hey, are you alive? Are you alive? Are you alive to each of these HA proxies? And if not, it's going to consider it down, and then this node with Keepalived won't be used. So really, this is kind of checking out on HA Proxy and saying, hey, are you alive? If it's not, it's going to take itself out, and make sure that you're always going to get routed to the Keepalived that's alive. Then after that, based on its checks of these Postgres servers, you're going to get routed to the one that is the current leader. So pretty cool. So let's create this check proxy script really quick. Let me just execute that, and let's paste in this script right here. So paste, right, exit. So paste, right, exit. So paste, right, exit. So let's create that user that's going to be executing the script because we don't want to execute it as root, and they cannot sign in, just creating the user on all three. Then what we're going to do is make this script executable. We're going to take ownership of it with this Keepalived script user and group, and then we're going to apply some permissions to it. So let's do that. Executable plus permissions, executable plus permissions, executable plus permissions. Now we can restart Keepalived to pick up the new configuration. Then let's check the logs really quick just to make sure it's running okay. Check the logs, so we can see here it's entering backup state, and then it entered master state right away. So let's see on the other ones. On 2, he's entering backup state, so he's doing what he should be doing. And on 3, he's entering backup state. So pretty cool. 1 is master, and the 2 are backups. Since these are running okay, we should have our VIP now. So back on our machine, what we want to do is ping that VIP. And my VIP is 192.168.60.110. And if we ping it, we get a response. So pretty cool. So now that this VIP is up, we can connect to our Postgres cluster. So how are we going to connect to it? Well, if you're really geeky, you can do it from a CLI, but I'm actually going to do it from a really cool application called PGAdmin. Now, PGAdmin is something I use almost daily in my day job to query, to write scripts, to delete data accidentally. But it's a really great open source application that allows you to connect to Postgres. It's one of the best. I'll put in some links on how you can find and install PGAdmin, but once you have PGAdmin open, let's register a new server. Let's name it HA Postgres, and then let's give it a connection IP of our IP address, or our VIP. I should probably fix that, of our VIP. And then we're going to connect as the username Postgres, and our password was inside of that config file when we bootstrapped the cluster. We go back to our Patroni config. You could see my super user of Postgres. Its password is right here. So let's copy that out and then paste it in here. And we should be able to connect. And let's see here, HA Postgres. Hey, it looks like we're connecting. So how can I tell? Because it would have thrown an error if not. Pretty cool. We are connected to our Postgres cluster. And you can see, hey, our dashboard's lighting up. You can see some transactions. You can see sessions. There won't be anything here right now because it's just us. But hey, we are connected. So we should test HA, right? This is the whole reason why we've been doing this. But before we do that, let's actually create some data really quick. In my documentation, I have a couple of scripts, one to create a table. We're calling it Nintendo characters. And then we're going to insert some of these Nintendo characters after we create it. So first, let's actually create the table. So we'll paste that there, and then we'll execute it. And it says table created. And then if we go under tables, we should see our Nintendo characters there with all of the columns that we created. Now that we have that table created, let's insert some data into that table. So we're going to insert a couple of characters here. And then in PGAdmin, let's paste that and let's execute the script. Now let's just do a select to make sure we have all of our characters. So highlight that, run a select, and you can see our characters here. So pretty cool, our database is running. So now let's introduce some chaos and start taking some stuff down. So the first obvious thing to do would be take down the leader of Postgres. Now I know that 1 is the leader right now, because remember, if we go into the logs and check our Patroni logs on that node 1, we can see it's telling us who the leader is. So this is 1, I'm PostgreSQL 1 leader with the lock. So let's actually go into each of these and log this out so we can kind of see what's happening. So in each of these Postgres nodes, I'm logging out the Patroni log so we can see what's going on. And so, yeah, 1 is the leader. Now let's take 1 down. And instead of stopping the service, let's actually shut it down. So let's shut this down really quick and let's go back to our terminal. And we could see almost right away, the Postgres 1 went down. Postgres 2, I'm the secondary, and following 3, and then 3, you can see here says I'm Postgres 3, I'm the leader with the lock. So pretty cool. It already failed over to node 3. And if we go back to PGAdmin, can we still select our characters and are they still there? If you see this, PGAdmin knows that we got disconnected. Most applications are going to reconnect right away. PGAdmin doesn't do that. But if we say continue and just reconnect to that same VIP, we can reconnect and executed the query. Again, most applications are going to auto reconnect when they get disconnected from the database, but PGAdmin didn't want to reconnect. So that's PGAdmin, happens all the time. Okay, but that's not important. What is important is we can still run our queries and we didn't have to change our configuration. We're still pointed at that VIP. Let's take some more stuff down. Remember, HA Proxy 1 is the master in this configuration. So let's take down the first HA Proxy. So let's shut down HA Proxy 1. Shut down. Yes. We look at our ping. You can see our ping's still going. We did miss 1, but our ping is still going to the VIP. If we go back to PGAdmin, we're going to run the command. It's going to say, hey, we got disconnected, but it's going to execute again. Pretty cool. We're still connected. Let's take down one more piece. Now HA Proxy 2 should be in charge because he had the highest priority outside of 1. So let's shut down 2. Shut down. And you saw we had 1 timeout from our ping, and we could tighten that up if we want to, but it's totally fine. But you can see our VIP is still up. If we go into Postgres, I know it's going to say it got disconnected, but it'll reconnect immediately. Yes, continue. And we could still see our list of characters. So pretty cool. We're in this state right now where one of our Postgres nodes is down, 2 of our HA Proxy nodes are down, but we can still get through the application and get to our data. So pretty awesome. So now let's go backwards and let's actually turn on these 2 HA Proxy nodes. And then let's turn on this PostgreSQL node. And let's see this one become the leader and synchronize the data back to it. But before we do that, let's make some changes while that node's offline. Remember, we shut it down when it already had characters. So let's add some more characters and then check it again after it comes up to see if it got the new data, proving that replication is working. So let's insert a couple more Nintendo characters here while it's offline. And so here's another 10 characters we're going to insert into this table. So let's highlight that, execute it. Got disconnected, but here we go. So it executed it. And now let's select. So now we should have what, 20 characters? If you see down here, we do have 20 characters. So now let's turn everything back on. Make sure that node 1 now has this data. Okay, so we're going to fire up HA Proxy 1, 2, 3 is already going. Turn on Postgres 1. Now they're booting up. Let's remote back into 1 when we can, and let's look at the Patroni logs. And so he's saying, hey, I'm secondary and following the leader of 3. And if we want to make this one the leader, I think we would have to shut down 3 and hope that 1 becomes the leader. So let's shut down 3 just to see if we can get 1 to become the leader. I forgot we didn't designate 1 the leader, they just elect the leader. So let's shut down 3. Oops, if I shut down the server, hey, but it's pretty resilient. So let's shut down the Postgres server, not the HA Proxy server. And let's see, what is going on? All right, so it did happen. So 3 went down. There was an election. You could see right here. You can see right here, lock owner. So he became the owner, updated leader lock during promote. So he got promoted to leader, did some checking, and now this Postgres 1 is back to the leader while 3 is down. And you could see node 2 is following 1. So if we go back and run this command, obviously we're going to see that disconnection warning, continue, and you can see that we have 20 characters. So setting up a high availability Postgres cluster is a lot of work, but now we have a cluster that's production ready and we can scale by adding more replicas. In the future, I'll show you how to do this with containers and Kubernetes and even backing up databases, but this video's been pretty long, so we'll have to cover that in a future video. I'm Tim. Thanks for watching.